So hello, everybody. As announced, I'll be talking about the updates and improvements in the latest PVSyst versions. And as I said, as mentioned already before, the last PMPC workshop was 2 years ago. At that time, we're still at PVSyst version 6.8.0. Today, we are at 7.2.17. And in the meantime, a lot of improvements and additions have accumulated. And I will be going very briefly through a set of them, which seem to be, to me, the most important ones. I'll be going very fast through this. So if you want to know more details on a specific topic, you can come to me during the breaks or also to my colleague Michele, who gave a talk in the morning session. So I'll be talking a little bit about improvements in modeling, improvements in tools that we added to the software, the user interface, and upcoming features. So first of all, PV components, most important ones are the PAN and OMD files for describing the PV modules and the inverters. We added a tool. First of all, we made the procedure itself simpler to introduce new PV modules in the database from datasheets. We made also tutorials for that, video tutorials, so that it's now much more straightforward to add new models, PV modules to the PVSyst database. And we added this tool here that you see on the bottom for checking or determining the series resistance in the single diode model, which is a very sensitive parameter, especially for describing the low light behavior of the PV modules. And this now can be done in a much more interactive and simpler way for our users. We also added a detailed electrical description of the twin half-cut cell modules. So in the most detailed description of PVSyst, where we describe the electrical behavior on the submodule level, so on the bypass diode level, we have now the twin half cell modules that can be modeled, and you can make the detailed, what we call the module layout in PVSyst using these PV modules. Yeah, and then I think Michele also gave examples of this morning. And then concerning power optimizers, we have now more manufacturers which are modeled. This is not as generic as a PAN file. You cannot put your own power optimizer into the database. So we have to model the specific behavior of the manufacturers. And so we added to that and improved the modeling of those devices. We have a new tool in there, which is called the aging tool, which allows to do multi-year simulations, including the PV module degradation. So we had this model which describes the year-to-year degradation of the PV modules. That's already in PVSyst. And we have now this tool where you can select a typical year or a measured time series and run your simulation automatically over these many years. And in the results, you see the output of your PV system or the performance ratio as a function of the years, including this PV module degradation. Then for the modeling, we have now an explicit treatment of the circumsolar irradiance. It was mentioned already in some previous talks that it's important to make this separation. So typically in the transposition models, you have the direct or beam irradiance, the circumsolar and a cone around it, and the isotropic diffuse. Up to now, or in former versions, PVSyst was treating the circumsolar for the shadings as if it was isotropic diffuse. And this was giving uncertainties, especially for high tilt systems and vertical systems, vertical east-west systems. And now the circumsolar shading effects is now treated separately and improves the accuracy of the results. Then to give a little bit more flexibility for the system design, we have added a little bit more detail to the AC part of the system. So you can now have 2 levels of transformers, a medium voltage and high voltage transformers, and you can define cable stretches between the inverters and those transformers and between the transformers. We have now an unlimited number of subarrays. So in PVSyst, if you want to describe a more complex system where you have different module types or different string lengths or MPPT configurations, you have to put this in so-called subarrays. Up to now, we were limited to 8 subarrays in PVSyst for that, and this limitation now was completely dropped, so you can design quite complex systems, and they are not limited by that number anymore. Then shading is an important issue. We have many users which are doing more and more complex systems on undulated terrains or on some kind of topology. And there were many requests of improving the tools in PVSyst to handle these kind of systems. So we now allow importing of 3D drawings from other software packages as well, where you can make a complex design and terrain layout. And we can import from these formats single axis trackers or fixed tilt sheds, fixed tilt tables. We support different formats, DAEs, 3DS, H2P, and PVC. And we can also import terrain from this external software. And this PVC format, just it's not a universal format. It's something that we define together with other software developers from external tools. It's based on the Collada format, which is its DAE format. And it allows you to define in there the PV modules and the trackers that then are directly imported into the PVSyst drawing. Just for supporting the users, we also added some visualization tools for understanding the orientations of tables, because we're getting lots of support questions on that. And this visualizes quite nicely that if you have a table and the baseline slope and changes, that the orientation changes, so the tilt and the azimuth, effective tilt and azimuth change. So you can see that now nicely if you have doubts about what PVSyst is calculating is correct. Then we also added some advanced editing tools to make life simpler for complex systems. So we have now multiple selection editing. So you can group tables into groups, and then you can apply changes to the entire group on a lot of parameters. You can apply filters to do a complex selection and then change this. So this makes life much easier for these more complex and larger systems. And for the backtracking, we also improved this. So in PVSyst, the backtracking algorithm assumes modules on a flat terrain and with a fixed pitch. And so far, what PVSyst was doing, if you had a complex terrain and undulating terrain, was choosing two tables for the worst case of backtracking and applying this algorithm to everything. And now the user has a possibility to choose himself the two tables that will be used for determining the backtracking parameters. Yes, you have some flexibility in there. You don't need to choose the worst case. You can try to find some average parameters for them. And another thing we added is filling zones with automatic filling of tables. So you can, in your drawing, you can define a zone and some exclusion areas, and then define the type of tables and give some rules for filling out this. And then PVSyst will automatically fill this region with tables or with single axis trackers. You can choose that. And yes, it will also adjust, optionally adjust it to the topology which is underneath. Yeah, so these trackers or tables can then follow the topology that is described under there, or be on a flat roof, for example. Then it will be flat. Another thing which was added upon a request of several users was the possibility to have trackers with vertical axis, but which have a single common axis. So normally the vertical axis trackers in PVSyst are tables where each table has its own vertical axis. And people were developing systems, floating systems that would be able to turn and follow the sun in this way. And then for this, we added the possibility now to have a common axis for a group of vertical axis trackers in PVSyst. And then this can now turn and follow the position of the sun. Concerning weather data, we have also done some updates. So the built-in PVSyst, for this, you don't need any internet connection, you just need your PVSyst installation is Meteonorm, and we are now at version 8. And this version 8 is also prepared for sub-hourly data. So PVSyst does not do a sub-hourly simulation yet, but the data that is built in from Meteonorm supports it already. So this can be done then in a subsequent step. We have added APIs for weather data. Meteonorm, Solca, Solanera, a few of them. Some of them also allow to import horizon lines, like you see down here, PVGIS and Meteonorm. So you can now, with clicking on a button, import these horizon lines into PVSyst. And PVGIS also allows you to import automatically multi-year time series. And for using these multi-year time series, we also added a tool that makes you allows you to make a TMY generation from a set of measured years. So you select a time series of measured data that you imported, for example, from PVGIS, and then you define the algorithm that is used. You can either use the one from the standards. There are some published algorithms how to create a TMY file from a time series, and you can even customize completely the algorithm that is used to generate this, and then immediately PVSyst will show you the result of this typical year, and then you can save it and use it in your simulation. Then we overhauled the financial analysis that we do on PVSyst. It was quite simple in the beginning, but now it's fully customized for the cost breakdown. You can add your items in the list of items, and with this cost, you can easily save and import them from a database. You can make a detailed financing plan, adding more loans and customized, including depreciation, inflation, taxes, etc. Also, the tariffs that you can define for the analysis are now much more flexible. So you can have several scenarios, on-peak, off-peak, seasonal variations, or you can even import them from a CSV file and have completely customized tariffs that you will use in your analysis. And then in the results, you have now a more detailed analysis with more variables that we added, LCOE, NPV, ROI, etc. And this economic evaluation includes also scenarios of self-consumption and storage, and has been extended also to standalone and pumping systems that you can simulate with PVSyst. And one nice thing is that it's integrated into the batch simulation optimization tool, so you can do an automated optimization also using the financial analysis. So not making only an energy optimization, but an economic optimization. Finally, we have, in general, tried to improve a little bit the user interface, which was getting old. So we overhauled also the report with many possibilities of customization. Here, an example how to customize a cover page. You can put a lot of information in there and really customize it to your needs. We made a completely new look for the interface in release 7.0, so it looks quite different than in version 6. And we added the possibility to make a direct comparison of two simulations. So you select a pair of simulations. PVSyst will put the two reports with all its pages next to each other and highlight the differences you find. And this is very convenient. If you make a small modification and want to see the impact on the result, you just push these two results and you have highlighted the results there. Finally, there are some minor or some other improvements in the user phase. So we have now direct feedback during the simulation. So the result builds up as the simulation executes. Is particularly useful for large systems, which takes some time to simulate. If you see that something is completely wrong there, you can abort immediately and then change it. Or you can get an estimation during the simulation already of your results. We have much more detailed of issues found during the simulation. Yeah, so you have a detailed report of issues that PVSyst detected for each individual simulation step, if there's something fishy going on. We added more languages for our users, so especially some Asian languages, Korean, Chinese, and Japanese are now also translated in the user interface and the report. And we are adding a lot of tutorials on YouTube and Vimeo, so video tutorials, and we are producing more and more. You have something like 40, 50 tutorials right now, and we are constantly producing more now. So finally, the upcoming features. So for the next version 7.3.0, which will be published in a couple of weeks, we think, there is, first of all, the single line diagram, which will be available. So this gives you the possibility to visualize and see that the definitions you did in PVSyst correspond more or less to the system that you want to simulate. And in the beginning, the single line diagram is mostly thought for visualization, so that you see what you defined in the system of PVSyst. But little by little, we will open this up. We have an editor which will allow you to edit parts of the system directly in the single line diagram and not anymore in the dialogues of PVSyst. We have added system summary and notes, so you can have a detailed system summary in written form to make sure that all the parts in your system definition are consistent and coherent, with warning and error messages if something is wrong. And you can add now custom notes to your simulation and have your own log and your private annotations, which are saved with each simulation. You don't need to save them or keep a separate log anymore. Then for this is also version 7.3, and on a little bit longer term, we are adding a model to simulate the sub-hourly clipping losses. So if you have if you work with hourly averages and your average is below your clipping level, and you have irradiance fluctuations, you can have some clipping losses which are neglected. Yeah, if you just simulate with this average, which is below the clipping level. And we use an approach that determines from the sub-hourly irradiance data, coefficients that are stored with the hourly data, and which allows us then in the simulation to estimate these additional losses. And this approach will be presented in September in the World Conference of PV in Milan. And then after that, we will implement it in PVSyst. And on the long term, we'll also in this trend of allowing to simulate more complex system, also give more flexibility with orientations and simulation. So right now you can have 8 different orientations that in simulation. We'll drop that limitation, and we'll even allow to mix systems like a tracking system with a fixed tilt system. You can, in principle, then put it in the same simulation. So it's a generalization of the approach, which allows you really to be completely flexible in terms of orientations of your PV system. And then we are also working on a more generalized bifacial model. So the current bifacial model is based on a 2D cross-section of your rows. So it's a simplified model, which is only valid for very regular systems. And we are implementing a system which will work with a 3D drawing. So really allow you to make a map of the ground of the reflected irradiance and then get a more accurate, not only more accurate, but a more general approach to describe the bifacial systems. So this is basically what I wanted to present today. You have here the list of everything I went through. I will not read through that. If something is interesting for you, you can come to me, and I thank you for your